Welcome to the second part of the RDF and RDFS class. Here we will be looking at the RDF syntax. So first we want to start with a definition of RDF. The RDF or the resource description framework is nothing but a language for representing information about resources and entities in the web. If you recall from the previous video, you've been pointed to the RDF primer, where you can find a formal definition of RDF. You need to think of this language as a language that is used not necessarily for people to process and understand situations, but mostly for machines to be able to understand information on the web, to be able to understand it, to be able to exchange it, to be able to reuse it in specific applications. Before we dive into the actual syntax, we will be stressing a lot the difference between RDF syntax and the RDFS semantics. So you always need to remember the difference between what is syntax and what is semantics. Syntax is how a symbol is being represented in a certain language. And while semantics is what actually the symbol means. This is the same as the semiotic triangle, if you're familiar with linguistics concepts, where you have a symbol that actually expresses a certain concept which is in our head, and this concept is also reflected then in the real world. So this is what is called the referent. So in the same way, semiotics distinguish between syntax and semantics. This RDF also distinguishes in knowledge presentation on the web. We distinguish between these two concepts. We've been talking about databases in the previous video. Databases also have syntax and semantics. So the structure of a database, the way you decide to create tables, is its syntax, while what it actually represents is its semantics. Now onto the basics of RDF. The main idea of this language is to be able to identify resources on the web using identifiers. And an identifier on the web is a URI, so a unique resource identifier, which can be reached on the web through HTTP requests. And these resources are not only existing in the web through a URI, so that they are named in the web through their URI, but they're also described in terms of the properties and values of that these resources have. So remember what a web identifier means. RDF relies on uniform resource identifiers, and a resource is anything that can be identified in the web by a unique URI. Now, this to give you an example of what does it mean to create a resource on the web. Imagine a small graph where you have Bob, which is interested in the Mona Lisa, and the Mona Lisa that was created by Leonardo da Vinci. Here we have, we could think that Bob is a resource existing on the web. So this is he would be identified by his own URI. We don't use URIs in this moment, in this picture, to simplify a bit the concept. But you need to imagine that Bob has his own URI on the web, and then we know a certain number of properties and values about Bob. For example, we know that Bob is a friend of Alice, that Bob is a person, that Bob is born in 1990. And then we also know that Bob is interested in the Mona Lisa. So Bob is a resource, its property is being interested in or born on or is a, and then the value is whatever is whatever comes at the end of the property. So in this case, interested in the Mona Lisa. So this is actually your first knowledge graph. You will be seeing more knowledge graphs in this course, bigger and bigger, hopefully. As I said, this is a simplified version. We will be looking at more complex cases later on. Going back to the definition, we said RDF allows you to identify resources using URIs and to describe these resources in terms of properties and values. Once we do that, what we actually start doing is we create a small graph, which is a set of statements or a set of triples. A statement and a triple are the same thing, which can be considered a description of a resource, its property, and its value. This means that we have the triple Bob is interested in the Mona Lisa. We have a triple Bob is a person. We have a triple the Mona Lisa was created by Leonardo da Vinci, or Bob is born on the 14th of July, 1990. Every set of a resource, a property, and a value is considered a triple. And it's most of the time, this is represented as a tuple with 3 elements. So in terms of terminology, what a triple is composed of is 3 elements, as we said. The first element is called a subject, which identifies the thing the statement or the triple is about, in our case, Bob. The second element is called a predicate, which represents a characteristic of the property that describes this subject. So in one of the examples in the graph before, the predicate could be is interested in, and then the object is the value of the property. So the third element in the triple is called object, and it represents the value of the property, in our case, the Mona Lisa. Keep in mind that predicate and property are often used interchangeably. As we said earlier, RDF uses URI to identify and give names to all the elements in a triple. So every subject, predicate, and object will be represented through a URI. We will see more examples later on. A small note on the URIs. You're probably more familiar with URIs because you use them when you type, and when you want to navigate with your browser, with your web browser, and you are going to open a new page, you often type a URI. Or maybe you click on a URI and you land in a new page. RDF and web browsers interpret URIs in different ways. So they both use URIs, but they are interpreted in different ways. With RDF, URIs are only used to identify things, which means that you create a new graph and you use URIs to identify your resource, your property, and your values, but it doesn't mean that they are necessarily existing on the web. Web browsers use URIs to identify things, but also to retrieve this information from the web. So in this sense, web browsers do an extra step. If you create a resource, giving it a name with a URI, and you store it on the web under your website or your domain with your domain name, then a web browser will be able to retrieve information from it. So the main difference is RDF only uses URIs to identify things, while with the browsers you can actually retrieve information about these URIs. So in order to distinguish them, what we do is that we use quotes to when we create resources, and when we write files in RDF, we use opening quotes and closing quotes to distinguish whether we are talking about the URI that is accessible via a web browser or the URI that is written in our RDF files. Most of the time, especially with existing data sets, we will see examples later. You will be able to take a URI that is written in your RDF file and put it in your web browser and ask it to retrieve information from there. So, for example, if you take this URI, wikidata.org/wiki Q12418, you will ask Wikidata, which is a large knowledge graph, to give you all the information this dataset contains about Mona Lisa, which means all the set of triples or all the statements that the dataset has stored about Mona Lisa. For example, that is a painting by Leonardo da Vinci, that and it has certain labels and descriptions. You are more than welcome to try it yourself. Now, going back to URIs, one of the problems that people face is that resources represented through URIs are quite ugly and they're very long to write. So the solution for that is to use prefixes and namespaces. So the idea of prefixes and namespaces is to allow users to write RDF and by shortening URIs. A namespace is considered as the root of any RDF resource. So a resource is always divided into two parts. The first part is a namespace. In this example, we have dbpedia.org resource. This is a namespace, and then the second part is the root of the resource, so which actually distinguishes the unique resource. So when you use names and a namespace and a root are always string concatenated, and then you obtain your URI. You could be replacing the root with another string, with another term, and you would probably access a different resource. You could try yourself, for example, to replace Mona Lisa with Leonardo da Vinci or Amsterdam, or a football team of your choice. When you want to shorten your URIs, what you need to do is that you need to declare the namespaces you are going to use by showing the prefixes that shorten this namespace. So when you will write your first RDF files, at the beginning of your text document, you will use this keyword @prefix, and then you will create a prefix of your choice. You can give it any name, as long as you use this notation @prefix, then the prefix of your choice, and then colon. And then here you specify the namespace you want the prefix to replace. This basically means that if I then write a prefix followed by the RDF root, it will be equivalent to using the full namespace and the root. In this example, dbr is the prefix that is being used for dbpedia.org/resource, and then Mona Lisa, dbr Mona Lisa is equivalent to writing http dbpedia.org resource Mona Lisa. This is really common and is a good practice, and I recommend you to use it as much as you can. You could also use an empty namespace. So you will see very often that you have resources expressed by nothing and then column and then the RDF root. So we could say just column Mona Lisa. This is also possible. So it just means that it's that the prefix is empty, but you can only use it once because prefixes are unique represent only one namespace. Now, notice that the W3C consortium, so the web consortium that we also saw in the earlier videos about the main reference for RDF, tries to gather all common namespaces. This means that there's lots of people over the years that have been using the same namespaces over and over. And in order to promote data reuse and interoperability, the W3C has decided to collect all these namespaces and the prefixes that are often used in a particular location. This means that if you go on this website, prefix.cc, you will always be able to say, if I have this prefix, what is the most common namespace that is being used? And then the answer would be dbpedia.org/resource. Or you can do the other way around. If I have this namespace, what is the most commonly used prefix? So again, you're more than welcome to try this resource yourself. It will be quite useful later on for creating your own projects. Now back to triples and the RDF basics. We've talked so far about the resources, but you need to remember that there are two other types of resources, so not only URIs. There's also literals. So literals are values of a subject which cannot be identified by a resource on the web. The typical case is the age of a person, maybe the address of a person, or the name of a person. So this is information that you cannot really identify with a resource. 34 is not a resource. An address is not a resource. So what the solution for or a telephone number, for example. The solution for that is to use literals. These are values that a subject can take. So, for example, Ilaria is age 34, or the Netherlands has name Netherlands, but they cannot be identified directly by a resource, so we use a literal for that. You distinguish literal because most of the time they are marked by quotes. With numbers, this is not mandatory, but you will often see them also. You will often see numbers in quotes as well. So somehow, if we look at this example, Netherlands here is a resource because this is the actual concept that we want to describe. So this is not the name. We could give it any name. So this is just a symbol. This is a resource that we want to describe with all the properties and values that we know about the Netherlands. And then we have as capital, this is a predicate. And Amsterdam is also a resource because it can be described with additional properties, with a mayor, and the number of inhabitants, etc. And then Netherlands actually has literal value, which is its name, and this literal value is the actual name that Netherlands take. This is one type of objects of values that you can represent in a knowledge graph. And then we also have blank nodes. This is a concept that you won't be using that much, but you can often see being used in existing knowledge graphs. And you need to think about blank nodes as a resource that is anonymous. This means that it's a node in a graph. For example, the North Pole is a concept in a graph, and then the North Pole has a geographic location. This is an empty node. We don't really want to describe it, but what we want to describe is the actual longitude and latitude. So most of the time, blank nodes are used to represent complex structures. So we talked earlier about addresses, but an address has multiple information. An address has a street, it has a street number, maybe a house number, it has a postcode and a city. So an address is a complex structure that can be represented with an empty resource. So we could say Ilaria has an address, and then here we would have street name, street number, postcode, city, and so on and so forth. So you need to remember, the only thing you need to remember about blank notes is that they are anonymous resources. So it's not, what matters is not the resource itself you're representing, but more what the resource is further describing. We will be seeing more examples later on, and this will become clearer. Now that we looked at the different elements that can appear in a triple, you need to remember that there are specific rules of what can be positioned, what can take a certain position in a triple. So URIs can appear in any position in a triple. So a URI can be a subject, a predicate, and an object. Literals, so we said when we want to express ages or we want to express telephone numbers, they cannot appear in subject position, they cannot appear in predicate position, they can only appear in object position. So think about literals as just values. There's no relationship that you can further express from a literal. So once you've said Ilaria as age 34, there's nothing else you can express beyond 34. While on the other hand, if you take Netherlands has capital Amsterdam, then you can further express information about a URI referenced. The same way, blank notes can take a subject position, but they cannot appear in a predicate position. So that this is just a modeling choice. It's just considered meaningless, and it would just be confusing. Most of the time, you will either see them in subject position because they further express information, or in object position. We will see more example of this later. Getting down into the abstract syntax of RDF, if we want to be more formal, we need to think of RDF as a set of 3 vocabularies. These 3 vocabularies is the set of URIs, the set of literals, and the set of blank notes. And in this sense, we can then define a set of triples as the combination of either U and B, so either URIs and blank notes. An element from the URIs, so in predicate positions only URIs can appear, and then in object positions anything between an element of URIs, blank notes, and literals can appear. So once you have defined a set of triples, then a knowledge graph is a set of triples that exist, that can exist in the set T of triples. So going back to the small example, we said we don't use URIs in this picture just to simplify, but we could consider that Bob belongs to the set of URIs, that the Mona Lisa belongs to the set of URIs, because you have further information being expressed. Leonardo da Vinci is probably belonging to a set of URIs because he also has a birth date and the death date, and the set of literals could be 14th of July because we can't really express anything else beyond this value, and maybe this audio file that is about Mona Lisa can also be considered a literal. In this example, we wouldn't have blank notes. There is another, once we create a knowledge graph, so once we create a set of triples, so remember the definition of a knowledge graph as a knowledge graph is a set of triples. So this now, the picture we're looking at, we will be calling it a knowledge graph from now on. Once you create a knowledge graph as a set of triples, or as we say, a set of RDF statements, one thing that we can do is that we can cut this knowledge graph into multiple pieces, so multiple subgraphs. For example, if you look at the color in this picture, we could say that we have a subgraph that describes information about Bob, and a subgraph that describes information about the Mona Lisa. So these subgraphs are called named graphs. A name graph is nothing but another URI that identifies a set of RDF statements. And the way you represent this is by joining together the statement and the name the URI that you gave to your name graph. So in this case, we call this name graph Bob graph, and then we represent all the triples that are inside this name graph as belonging to the Bob graph. So Bob is friend of Alice, is a triple that belongs to the Bob graph. Bob is born on the 14th of July, is 1990, belongs to the Bob graph. And Bob is interested in the Mona Lisa, is also belonging to the Bob graph. Name graphs are very useful when you have a very large knowledge graph and you want to query only one part of the information without having to look through the entire graph. So it's a very elegant solution to simplify querying and in your applications. We will see more example of that later. Once we have, so we've been through the basics of RDF, which means we now know how to create graphs. One thing the following step is to know how to save RDF files. So saving them or storing them or serializing them can be done using different formats. This is the set of the most common formats. There's other ones, but the most common ones are RDF XML, which is a bit old-fashioned. Turtle is very human readable, so it's the one that you will see the most. It's the one that we will be using. You have triples, which basically represent a graph as a set of triples, and every line in your file is a triple. Is an extended triple. And then there are certain graph-friendly formats like trigs or trig, JSON-LD or nquads. There are formats that can be combined with HTML. So you can annotate RDF on HTML pages using RDFA. It's not that uncommon, but you need to look for these kind of files. To give you an idea of what we're talking about, RDF XML, this is a knowledge graph expressed in RDF XML. So here you have, you see that there is description about a resource. This resource is about an event. And then here you have the set of predicates that the graph knows about this event. So this event is of type node. This event is of type has a tick of 25, has a pitch of 45, has a channel of 2, and has a velocity of 120. So we probably know from this that we are talking about some data representing the musical domain. Here you have so it's the representation is very similar to XML. Here everything in these lines is a description of a single resource. Here you have another resource. Here you have another resource. And if you recall the prefixes we saw earlier, mid is probably a prefix that replaces that replaces a namespace, which is likely to be example.org/MIDI, Ghostbusters. And then you have another prefix here, RDF, which is the most common namespace for the resource description framework. Now we have the n triples, as we said, is a format that represents triples, one triple per line in an extended format. So here you have subject, predicate, object, subject, predicate, object, and so on and so forth. Recall, as you can see here, the objects are quoted, which means these are literal values. They're not resources. The only resource we see in object position is this note on event. Turtle represents the same information. So we are looking now at formats that are representing the same information. And here you see, okay, we have a track that has a certain number of events, and then a specific event. So this is subject, predicate, object, and then this is the shortened version of the Turtle allows you to shorten the representation of the triples. We go into that in a few slides. Enquads and trig allow you to serialize and store name graph. So this is in this case you have a graph that you have in your file. You represent your triple and the graph the name graph where this triple is stored. This can be done both with enquads, with the enquad format, or with the trig format, which is an extended version of Turtle. So here you have the graph where this set of triple belongs to. Just a few syntax rules before finishing. In your RDF files, you can always add comments. They have to start with a hash character. Remember that URIs are always surrounded by quotes. If you don't, this is a syntax error. So opening quotes and closing quotes. Triples or statements are always terminated with a period. So if you say Amsterdam is of type place, you need to add a period at the end. You can use A to abbreviate RDF type. This is a special, RDF type is a special keyword which allow you to give a class to your URIs. We'll see this in the next video. And so you can say DBP Amsterdam A place, or you can say RDF type place. It's the same thing. So you can replace A and with RDF type with A. Remember to enclose literal values in double quotes. So Amsterdam has an official name, which is Amsterdam. You can together, when you express a literal value, you can always specify the language or the type of information you are giving. This is the same way as typing in programming languages. So if, for example, you are giving a label Amsterdam and you're saying, okay, this is Amsterdam, but it has to be read as the Dutch language. So you use this the @ symbol, or you could have English or DE for Dutch, for German, and so on and so forth. You can also express the type of a number. So it can be an integer, it can be a float, it can be a double, and so on and so forth. You can, as we said, we can write numbers and booleans without quotes, only numbers and booleans. This means that if you have a string value, strings have to be quoted all the time. To avoid confusion, try to use quotes always, so that you don't get confused. Additionally, you can, when you write triples, so we have Amsterdam has an official name Amsterdam. Amsterdam has a total area of 21 million square meter, and Amsterdam has a leader name Eberhard van der Laan. This is also actually outdated. What you can do is that you can use a semicolon when certain statements share a subject. So you see here, these three triples share the same subject. What you can do is then you can shorten this notation by saying Amsterdam as an official name. Amsterdam, semicolon, area total, 21 million, lead name, Abraham van der Laan, full stop. So you use semicolons when you have triples that share the same subject, and then you see that the predicate changes and the value changes. Additionally, when you have triples that share both the subject and the predicate, you can use a column. So the Netherlands, RDF label Nederland in Dutch, then the Netherlands in English, and then Pays-Bas in French, full stop. So here you use a comma. And these things can actually be combined. This means that the Netherlands has multiple labels. Then you say Nederland, comma, the Netherlands, comma, Pays-Bas, semicolon. Then you change, the predicate changes, and therefore this is why you use semicolons. And then you close your final statement with a full stop. So this is the notation that you will see and you will learn with practice. If it gets too complicated, you can always write your triples in an extended format. And blank notes, we discussed about blank notes. They are designated with underscores. So the foo has a certain address and then underscore some address. And then you specify, so the sum address has specific information like the place, the street number, and the postcode. Then you see here that since the predicate changes, we are using semicolons. Then so blank notes can either be designated with underscores or with squared brackets. So you can also say the same thing that we expressed before with a different notation by saying foo has a certain address and then you have a square bracket. So the square brackets basically replace the empty name sum address that we gave before, but the set of triples remain the same. This is the end of the second video. Thank you very much.